Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a x square minus y square equals to 51, and we solve this problem for all the values of x and y. So here you see that in the left hand side this is the very famous algebraic formula, and we know about that x square minus y square is equals to x minus y times of x plus y is equals to 51. And further in the next step, you see here in the left hand side we have there are two factors are multiplied by each other, but in the right hand side we have only one factor. So we need to convert our right hand side into the form of product of two values x and y. But here you remember one thing is that here our x and y should must be belongs to the positive integer. It means that we solve this problem for only positive integer values of x and y. So here we first find the possibilities in which the product of two positive integers becomes 51, and we have the possibilities are 1 times of 51 is equals to 51, and 3 times of 17 is also becomes here 51. So we have there are two possibilities in which the product of two positive integers becomes here 51. So it means that we divide this case or this equation into the two following cases. So here we write our first case, and in the first case we compare x minus y and x plus y with 1 and 51, and we write it as x minus y is equals to 1 and x plus y is equals to 51. So here you remember again one thing is that if we make the relation between x and minus y and x plus y, you say that x minus y is always less than x plus y. So here we choose we equate those factors in which the first number is less than the second number. So if you see here 1 is less than 51 and here 3 is less than 17, so 1 and 3 are lesser terms, so we equate it into the x minus y, and 51 and 17 are greater terms, so we equate it equals to x plus y. So this is our first case, and here in the parallel we write our second case. And in the second case we compare x minus y is equals to 3 and x plus y is equals to 17. And here in the next step we need to solve both of these two cases, and we easily get the values of x and y. And here we call that this is our equation number 1 and this is our equation number 2. And when we add equation number 1 and equation number 2, we have this is negative y and positive y are gone, and we get here x plus x becomes 2x equals to 1 plus 51 becomes here 52. And in the next step we need to find the value of x, and for this we remove this 2 from here, so that's why we divide both of the sides by 2. This 2 and this 2 are gone, and we get here x is equals to this is 2 times 2 becomes 4, and 2 6 are 12. So we easily get the value of x is equals to 26. So this is the first value of x, and you clearly see that our x should must be belongs to the positive integer. So we use this value of x into the equation number 1 or equation number 2, and we easily get the value of y, so that we use this value of x into the equation number 1. And now we copy down equation number 1 here. It is x minus y equals to 1, and our x is equals to 26, and 26 minus y is equals to 1. And here we move minus y to the right hand side and 1 to the left hand side. It will becomes 26 minus 1 is equals to y. So we have 26 minus 1 becomes 25 is equals to y. So this is the value of y which we get here in this method. And in the next step we move towards our second case, and in the second case we again get the other values of x and y. So we call that this is our equation number 3 and this is our equation number 4. So here we again add equation number 3 and equation number 4. So this is negative y and positive y are gone, and we get here x plus x becomes 2x is equals to 3 plus 17 becomes here 20. And here further we again divide both of the sides by 2 in order to get the values of x. This 2 and 2 are gone, and we obtain here our x is equals to this is 2 times 10 becomes here 20, and we get the value of x is equals to 10. So this is the only one value of x. We use this value of x into the equation number 3 and we get the corresponding values of y. so that we put this value of x in equation number 3. And now we copy down equation number 3 here. We have x minus y is equals to 3, and the value of x is equals to 10, and we get here 10 minus y equals to 3. So here we move minus y to the right hand side, and we move 3 into the left hand side, and we get 10 minus 3 is equals to y, and 10 minus 3 becomes here 7 is equals to y. So you see that from both of these two cases we will obtain there are two solution sets or two roots of the given equation. So these two roots are the first root is 26 and 25, and the second root is 10 and 7. So in the next steps we need to verify that is these values of x and y be the solution, or is these values of x and y be the extraneous root. So for verification of this we need to copy down given question statement. Here it is x square minus y square equals to 51, and here in this case we substitute the value of x and y in the left hand side. So here we have x is equals to 26 and y is equals to 25. So when we put both of these two values here, we obtain 26 square minus 25 square is equals to 51. So here you know about that 26 square becomes here 676 minus 25 square becomes here 625 is equals to 51 or not. And when we subtract both of these two values we clearly get here 51 is equals to 51. This means that the first root is satisfied our given question statement, and in the same pattern we verify the other values of x and y. So for the second case we have the other values of x and y is equals to 10 and 7, and we substitute 10 and 7 into the given question statement, and the given question statement is copied down here. It is x square minus y square equals to 10, and when we put both of these two values here we get 10 square minus 7 square is equals to 10, and 10 square becomes 100 and 7 square becomes 49 is equals to 51. So this is 51, okay, not 10, 51. So you know about that 100 minus 49 is equals to 51 equals to 51. This shows that both of the sides are equal, and if both of the sides are equal, this concludes about that the solution set of this problem is equals to uh, 26 and 25 and 10 and 7. So both of these order pairs are solution sets of the given equation. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more interesting and exciting videos.